Okay, in this video I'm just going to show you an animation of these couple of objects here, and the reason being is that I'm going to show you the difference between some terminology that I use, and you'll find this if I put together a playlist on, say, basic calculus and basic physics. And the reason I haven't done it yet is because, well, since Blender is mostly for artists and animators, the number of people who are really get excited about doing the more technical, complicated stuff really falls off pretty fast. So basically, I'm waiting to see just how much activity is in my Math for Animators playlist, whether there's a lot of viewers, whether a lot of people actually watch the ads, and whether there's much ad revenue generated from them. And then I'll decide whether I'll do more advanced tutorials like that. Otherwise, I'll have to go into my paid tutorials when my Sci-Fi Animator website comes up. And those will have to be separate from YouTube because you can't charge for YouTube tutorials. But the terminology I'm going to use, just so in case I sometimes use it in other videos anyway, when I run this animation, there's a couple things are going to happen. These are going to move at different rates. So now the orange sphere is taken off first, and then the blue sphere takes off after it. It starts at a much slower rate and catches up to it, and then it even accelerates past it. You can see it. Keeps going, and as it gets past it, even goes much faster. It keeps going faster and faster as it goes along. And the orange sphere, if we try and look at this close, is actually moving at a constant pace. So basically, for this, I'll specify this as a constant velocity. And sometimes I'll use the term speed, moving at the same speed, but those are not really the same terms. Speed and velocity tend to be a little bit different, and the reason being is that, say for instance, if I'm describing a car to you moving down the road and I say, oh yeah, the car is going 25 miles an hour, and I say, yeah, the speed of the car, I'll say, yeah, it's 25 miles an hour just consistently down the road. Well, that tells you one piece of information of the car. It tells you that it's moving at 25 miles per hour, but I'm not telling you what direction it's moving, whether it's moving east, west, north, south, something like that. Whereas if I'm using a velocity term, I might say it's moving at 25 miles per hour, but I'm also going to tell you what direction it's moving. And then that's when I'll be doing future lessons also that may end up on the paid tutorials on vectors, because vectors are just really super important. But then I get into calculus and more important stuff like that. But so if you hear me use speed, I'm typically referring to, how fast something is moving. And if I use velocity, I'm saying how fast it's moving and what direction it's moving. That's why vectors are represented by an arrow, because it points in a certain direction. Now, however, this blue sphere in here, if you look at it closely, it's accelerating. All right, it has an acceleration factor to it. So it's not moving at the same pace. It's starting off slow, and it gradually accelerates, and it keeps accelerating as it goes along in the scene. So, and this is actually, when you get into that, then you start dealing with a little bit of calculus, or you even see this in basic algebra with quadratic equations, because you can solve things like that with quadratic equations. And so that's just the point. But it is interesting, Blender's capabilities to do simple things like that. There's no keyframe set in this animation. All right, well, that's it for now, and I'll see you in the next video.